From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 93, recorded live Monday, December 10th, 2007. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. Support is also provided by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott discusses the test generation tool PEX with Microsoft researchers Peli and Nikolai and Nikolai Tillmann.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm sitting here in Microsoft Research on campus, and I'm talking to Peli and Nikolai, and I'm not even going to try to pronounce your last names. Peli, your last name is?
De Halleux.
Okay, and your last name, sir?
Tillmann.
So Peli and Nikolai are going to be talking to me today about PEX. And this is something that we were a little concerned we wouldn't be able to do a podcast about because it's kind of a visual thing, but I try to bring you the latest stuff here on the show, and I just thought this is something we need to hear about. I've been pushing test-driven development and things like code coverage for a very long time on the show. I think it's so important. We did a show on software metrics and the importance of things like cyclomatic complexity, maintenance complexity, to get an understanding of how complicated your code is. But while I thought I was getting an understanding that I think I'm testing my code in all the different branches, I realized that I wasn't even getting close. So, Peli, tell me about PEX and how this is going to make it even easier to test my code and have an understanding of what I've intended to do versus what reality.
So it's an automatic white box test generation tool. Okay. What does this mean? We automatically generate a test case that will exercise the code, and we figure out what to do by monitoring the code that is being run. So we are actually doing some kind of static analysis on the fly.
Okay, so I think that our readership might understand static analysis in the sense that there's like the basic example. You've got a method that returns a void and takes a Boolean. How many ways are there through this? Perhaps there are two. You could pass in true, pass in false, assuming that there's no branches and that you act on that parameter. You can look at that statically and make a judgment call, right? You could say, you could apply a value. This has a complexity of 2 or 3, right? That's static analysis?
That's static analysis.
Okay.
What we do, which is what our analysis does, is it monitors all the instructions that are being executed by .NET. And at some point, you will have a branching instruction. So you will load that parameter on the stack, and then you will decide whether or not to jump, right, to the else statement or not. So we record that. So we record that based on the parameter, you took a branch and not the other one. And we record the precise expression at that point.
So rather than looking at the code, parsing it, and making a static judgment about here are all the things that I think could happen, you're doing static analysis dynamically.
Yes.
So the farther you get into the application, the more you can see the branches ahead.
Yeah, so it's an iterative process, and the first time you will start with simple values, and you will probably stop at the first branch. And then you will try to create new inputs to take the other behavior. And then you might uncover more branches down the road on that path and so forth. So the more you iterate, the deeper you go into the system and the more you discover about what it's supposed to do.
So if I had a method that takes an integer and then I had an if I is smaller than 5, do you just go 1, 2, 3, 4, 5, 6? How do you know at what point you're going to switch, take the left fork of the road or the right fork of the road?
So PEX would start with 0, right? And we would have 0 smaller than 5 is true. So we would take the true branch and we would go on. And at the end of the run, we would remember that parameter smaller than 5 was true. So now what we're going to do is flip that condition. So we want that the parameter is greater or equal to 5. And then we send that, so we build a constraint system and we send that to an automated theorem prover which is called Z3, which is developed here at research.
So Z3, the theorem prover, is another thing. It's another component written by different.
Yeah.
Okay.
And you can check it out on the web. You can even download it and play with it. It's very interesting. So the theorem prover is going to give us a solution, and it might be anything. It could give us 5 if it's nice, but it probably would give us 1 million.
Oh, so it doesn't look at that and give you 6.
No.
It goes the entirely different direction, almost like a binary search. It's going back and forth.
It's probably going to flip a bit and check if the condition. I'm not sure. Nikolai knows more about the internals of the constraint.
Does it matter? I mean, ultimately, if you're just trying to take the other fork in the road,
it doesn't matter.
It doesn't matter.
And if down the road you check whether it's smaller than 10, then we'll do yet another run and we'll have one more constraint in our system. And then the constraint solver will actually give us the correct number.
So this is about getting coverage. It's not about covering every single input. I mean, certainly testing 1, if 1 is less than 5, we don't need to test 2, 3, and 4.
You don't. Actually, you don't.
And that saves time a number of ways, doesn't it? Well, I mean, PEX takes a while. You'd rather that this thing run all day if you could.
Well, when you look at random approach or approaches where the user has to provide ranges, random would, if you have the condition like I equals 1, 2, 3, right? Random would never find it.
I see.
Right? It has 1 over 2 over 32 possibilities. It will never find it.
I see.
If the number is sufficiently high and it's outside of the range that you gave it, you will also not find it.
So brute force is just not appropriate when we're talking about numbers in this size.
In many cases, brute force doesn't scale.
Okay.
To real problems.
So you generate tests. So actual C# is popping out of the results of this. So I write something, I annotate it with a PEX specific attribute to indicate that this is something that I want PEX to attack.
When you write a unit test, you don't give parameters usually. So the only difference now is that you can actually give parameters to your method, and PEX is going to use that to inject values into the system. And at the end of the generation, we code gen, so it's C# code that actually calls back the original method. And that's it. And once you have that, you don't need PEX anymore. You can actually run it with your favorite test framework and just go on.
So this is not code that's necessarily dynamically generated every single time. I might run PEX once a day, but my tests may be running within my continuous integration many, many times a day.
Yeah, so there are many different scenarios, but you might be developing code on your own on your dev box, and then once you feel it's ready and PEX generated 50 tests, you can actually check them into your depot, right? As unit tests and have them run by your continuous integration as unit tests, and you don't even need PEX on that machine at that point. Now, if you want to be more aggressive, you could actually have PEX run on the continuous integration server. So the interesting points here is that, 2 weeks down the road, the guy next to you changes your code, fixes a bug and then totally screws up your logic.
Right.
And your unit tests are not covering that. They don't capture that change of behavior. But PEX, because it has this parameterized tests, will start exploring the new code, generate new test cases, and might generate new failures, and
So in that case, not running PEX would be a bad thing. I want to keep it exploring this new code as the code evolves.
You probably want to have it explore, forever. The more time you give it, the deeper it's going to go into the code. If it's a large code base, complex, it will need a lot of times, hours, days to really go into those very, very, very deep corner cases.
So this sounds like something I might want to even dedicate a machine to and just have PEX running 24 hours a day.
Yes.
You're looking at Nikolai like, well, I guess
why not 10?
I mean, why not 10 machines?
Yeah.
Oh, so I thought I was being controversial by suggesting 1. You're thinking
it could be a quad core.
You're thinking a PEX farm. Nikolai, you had a comment?
I mean, think of it as your personal tester. And instead of paying a person a big salary, now you can have this huge farm of machines.
Suddenly I've fired a person now.
Well, so if you're really writing a lot of software, it's still a good idea to have dedicated testers which do integration testing. But a lot of tasks that can be automated, that is exactly what PEX is good for. So instead of having a person manually looking at all the parts of your code that are covered or not covered. A lot of that can be automated by PEX.
So we're talking about theoretical things and computational things, and of course these are difficult concepts to visualize when you're talking in an audio-only format like we are here in the podcast. But I can understand in a complicated computational environment doing lots of ifs and branches and for loops. But what if I started involving the environment, looking in the file system, talking to the database? What kinds of things can PEX help there, or in what ways is that not a valid thing? You know, when does unit testing become integration testing?
So PEX will definitely help you detect that you're not testable. So it will detect that you are actually reading a file or you're actually hitting a database and you haven't mocked it, right? Because PEX will not understand the file system. PEX understands manage code. It can monitor manage code. If you call a web service and go through the web or something, we don't understand the logic in there. So if you call file exist and you pass in a string, we cannot figure out which file name to make it true. So at that point, what happens? You get a bad coverage. So there's a branch that we cannot cover, and you will see that in the reports. So what does it tell you? It tells you that PEX couldn't solve that little constraint system, right? But it really tells you that for us, you should have mocked this. So you should have put a layer of abstraction between you and the file system so that you could actually simulate the return true solution, right?
That's very interesting because we had done a show before on mocking, and I didn't think I quite understood it. And now I'm starting to realize that in order to really get full coverage of your code, that mocking in this instance, mocking out the environment, physical things, abstracting away so that the logical intent is being tested is so important.
And actually, it's very easy to shoot in your foot when you do unit tests. It's very easy to file open. Everybody does that all the time. And it's actually painful to have pure code that is fully mocked, fully, inversion of control. And so it's actually a lot of work. Now, PEX will help you because it will not work as well as it should do if you start calling, another example, HTTP context. How do you handle this guy?
Well, of course, now in the new MVC framework, that'll be an interface.
Yes.
So that'll be great. So if I can mock all these things away, so PEX with the MVC framework would be a really good thing. I could get really good code coverage on my controllers, wouldn't I?
Yes. So PEX comes with its own mock framework. So it doesn't, it's similar in some aspect and it's radically different from all existing mock frameworks. So the big difference is that it's basically a source of choices. So when you call an API and say, give me a Boolean, you're basically asking PEX, choose between true and false, right? So you don't set the expectations. We do. And then we record that in the generated test.
Wow. Okay. My brain just exploded. So with mocking frameworks, you usually set up the expectation ahead of time and you say in a non-parameterized test, all right, this, in this case, will return false. If I was going to return true, I would have an entirely different test and then I would mock that and it would return false. So you're saying that I set up the domain. So it's a domain-based mocking system. I say, here's the domain is my range, rather. I say, here's the range of things that could come back.
You set a small behavior. It's a domain. So, a Boolean can be true or false, but, you can have behavior in that. You could also, Boolean is kind of not a good example.
Right, well, but what's a good example then?
Let's see.
What about the Visa card? You had an example earlier where you were doing something with Visa cards. I thought was interesting.
Yeah. So, we can mock the Visa card. So we have a service. You give it a string that's supposed to contain a Visa number and returns whether it's valid, invalid, or, whether it's valid or invalid. Now the logic that handles that couldn't care less whether it's a valid number. It queries a service which gives an answer. So the mock written the PEX way will say, give me a Boolean. And based on what you do with this Boolean, it will make it true or false.
Okay. So you're giving PEX the context that it needs around that mock to make the different kind of branching decisions it would need to get full coverage.
Yeah, so the Visa example is a great example to talk about test assumptions.
Okay.
So because if you look at your pocket, you notice all the Visa cards starts with the number 4. Whereas from other companies, they might start with a 5 or whatever. So when you want to check a credit card validation algorithm that checks whether all the numbers make up a valid Visa number, you should start by looking at the first digit, make sure it's a 4. So only under the assumption that the first digit is a 4, all the other digits have to be in a certain way for a Visa card.
Right.
So this is a test that has assumptions, and only under these assumptions it makes a statement about the other digits.
Right.
And when you write mocks with PEX, that's similar. So if you don't write assumptions on the mocks, PEX is free to choose arbitrary values. So if you have an API that you mock that returns an integer, PEX will choose any integer. No restriction on the domain whatsoever. Only then if you go in and make a statement about legal domains, or if you have assumptions about what the return value really should be and you don't care about others, then PEX restricts the different things that can be returned. So in that sense, it's radically different from other mock frameworks where you have to say precisely what is returned. With PEX, by default, anything goes, and only if you add assumptions, if you write them down, PEX will be more specific.
This is starting to get me to think that PEX is a lot like a chess solver. There are rules of the game, and you need to give PEX as much context as possible for it to make the right decisions. Otherwise, you're going to be generating tests that aren't useful.
Otherwise, it would try to kill the king with, 1/16.
Just take the pawn and then just smack the king on the head.
Yes.
And this is really interesting because from a point of view of static analysis, let's just use, the human brain looks at a couple of line long application and says, it looks like there's 2 or 3 branches there. Just by looking at it, we do static analysis with our heads. But you're doing static analysis in a dynamic way, in the sense that you're going to move that chess piece and then reevaluate the entire board and then move another branch and another branch and another branch. And in each step, you are discovering new things by virtue of the fact that you've kind of gone into the future. So earlier I asked you if a lot of this could be parallelized. That's when I was thinking that there was a body of work that was known and understood. It sounds like you're discovering, the longer you run, the more and more that you're going to discover.
There are opportunities to parallelize. We can dig into the details, but
sure.
Basically when you have a trace, so when you've run through the program, you might have gone through a large number of branches that you haven't taken. And for each of those branches, you need to solve a constraint system. So we might decide to parallelize this.
But not the branching, not the discovery of the branches, though, right?
Well, in our approach, you'll always need to pick the next branch.
Yeah.
And solve the constraint system and then run it and then go on. So
one idea here. So we could probably do a lot of this analysis in parallel. So right now we are doing it sequentially because that kind of guarantees you that you get a minimal test suite back from PEX. So only when PEX step after step can increase coverage, your test suite gets bigger and bigger. So every new test increases coverage. Whereas if you would do things in parallel, it might be that things are more redundant. So it's kind of a research problem to figure out how to really make it efficient and parallel.
Ultimately, we are running code. So we are actually running your code. And if you don't expect that and we start running in parallel, we might start, finding false positives, which is something that PEX doesn't have. All the failures that PEX will find are actual failures.
So how does PEX know when it's done? I mean, when can you test? Can you truly look at a method and test it completely?
So for certain methods, yes. But as soon as you have a loop or if there's recursion in the function, it's a theoretically undecidable problem when you can really stop. PEX doesn't know either whether if you go around the loop one more time, maybe then something new happens. So whenever you have loop or recursion, basically you tell PEX a time bound. You have 3 minutes time, and then PEX tells you all the things it could find within that time.
And this is why the mocking is so important, because as soon as you reach out of the theoretical into the physical, touch the file system, touch the network, anything could happen. Unexpected things can happen. And then the number of things that the size of what could be tested is infinite.
Right. So it gets infinite very quickly. And that's also why we had this idea of having a machine which just let PEX run forever, because you really can let PEX run forever when you have a loop, and every interesting program has a loop.
I think we should make a screensaver that runs PEX when the screensaver is going.
You might want to have a quad core for that.
All right. So let me get my brain around this. I'm just having trouble getting a visualization here. Traditionally, when I write unit tests, they don't have parameters at all. The first time I saw parameter tests were when I was first introduced to MB unit, right?
MB unit. Oh, I happen to have written that.
You did? I think that if I wrote MB unit, I would probably make T-shirts and I would just have it say, I wrote MB unit, buy me a beer.
Unfortunately, nobody in my entourage, especially my wife, really appreciate this kind of work.
That is a shame because that is an amazing piece of work. So the row test stuff in MB unit is really kind of its most famous feature, the ability to call a test and pass in parameters, iterate over a single test.
Yeah, I was a bit surprised by this one. People really like, I think, the conciseness of this little micro language, and definitely parameterized test is something useful in many cases, not all cases, but people just happen to like it.
Mm-hmm. Now, when you showed me the demo earlier where we did a test of the credit card, you ran through thousands, at least 1,000 tests within just a few seconds.
So we actually executed 1,000 times the actual tests with 1,000 different inputs, but we emitted 7 tests that actually yielded to different coverage.
So rather than generating a mess of C# with 1,000 tests, which would be the brute force method, which we decided earlier would not be a good idea, how did it come up with 7?
Actually, so the brute force method would be much, much more, because every number can be from 0 to 10, and there are like 16 numbers in each. So already the 1,000 was very cleverly chosen, and only 7 of them actually increased coverage.
So the 7 number wasn't set as a parameter. It wasn't anything that I had to say or you had to say. PEX determined that that was the correct number of tests for the kind of coverage that we needed. No?
It stopped. There's a bound on the number of runs. The default value is 1,000 runs.
Okay. So it discovered 7 tests that were correct tests that increased coverage given the limit of 1,000.
Yes. So there is a loop in the code that validates the credit card number, so it could go on.
So
if
I let it run all day long, it wouldn't discover thousands of tests. It would only discover as many tests as there were branches.
Each test increases coverage.
Okay. And is a credit card a good example of one where I could test it until it's done? I mean, I know that maybe this is silly for me to think that I could actually have 100% coverage, but I want to know how far I can squeeze this.
It's not a terribly good example, but in some sense, who says that all credit card numbers have to be of a reasonable length? What if we have a credit card number that is 1,000 characters long? Maybe your code breaks then. We don't know, and PEX would have to find out that takes some time.
So then this is where the assumptions come into to point of view, right? This is where you tell PEX, stay in this area. Is that correct?
The assumption will definitely restrain PEX from trying, to explore the entire state space.
Okay.
And you can just write an assumption. Let's assume the number is less than 100 in length.
Okay. Or in the instance of kind of the typical credit card, but it's 13 or it's 16, and stay in that space.
Yeah, definitely.
Or that's something that you would probably want to write as an assertion, right? So if it's checked, then it should be of that length. But what numbers do we even want to try to check? Well, they should be between 0 and 100.
So when would I want to use a PEX assumption to say PEX that we're assuming this case versus an assertion in a test?
So in the case of the credit card, you would assume that the first number is 4,
okay,
which is for Visa.
For Visas.
And then you could actually try to validate it and then assume that it's valid.
Okay.
And then if it's a valid, so your code that validates should have discovered that it's actually the right length for a Visa card number. And then you can actually assert on the length. So you can assert that the length should be 13 or 16.
If it met those previous assumptions.
If the first number was a 4 and it was a valid number, then you can actually kind of split your spec there.
So that by giving PEX that additional bit of context, it stays in the domain that it needs to be playing in, and then provides the most value.
And it becomes more meaningful to you.
Cool. So we'll put links to your blogs and the research project up on the show site to make sure that when people can go up and learn more about this. I know you've got lots of samples and articles that you've been writing about PEX recently. And hopefully we'll see PEX real soon, and people will be able to play with this project from Microsoft Research. I appreciate both of your time, Peli and Nikolai, for taking time out of your day to sit down and explain to me about how the huge brains in Microsoft Research work. I really appreciate it, and we'll probably do maybe some screencasts in the future so we can see some of what's going on with PEX.
You're always welcome.
Oh, well, thank you very much. And this has been another episode of Hansel Minutes. We'll see you again next week.